All right, 2019, number 4. Okay, let's just read through it real quick. We got a picture of a barrel with some water in it. A cylindrical barrel with a diameter of 2 feet contains collected rainwater, as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height of the water in the barrel with respect to time is modeled by this expression, or this equation, where h is measured in feet and t is measured in seconds. The volume v of a cylinder with radius, height, radius r and height h is v equals pi r squared times h. Okay, first thing, find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Indicate units measured. Okay, guys, this is really pretty basic. This first part should be pretty simple. They give us the volume equation. We want the rate of change of volume, so we just need to differentiate. We just need to take the derivative of this. So the derivative of v would simply be dv over dt, right? We do it all with respect to time, equals. Now, here's the thing that's important. As we filled this thing up with water, is the radius changing? It's not, right? The radius is a constant, and if the diameter is 2, then the radius is a constant 1. So I can think of this equation as pi, well, let's go down here. I could think of the volume equation for this thing as volume equals pi times 1 squared, which is really just 1, times h. H is the only thing that's changing on this side of the equation. So when I do the derivative of this, it's going to be pi times 1, right, because that's the coefficient. You could even think of it as 1 squared, doesn't really matter, times dh dt. If that doesn't really make sense to you, think of it like this. If I had 3x and I took the derivative of that, wouldn't it just be like 3 dx over dt, right? That's it. The coefficient stays the same. In this situation, the coefficient is pi times 1, or really just pi, okay? That's really all there is for this one. So what is dH/dt? We need to know what that is. Well, they told us what that is. So this is actually pretty straightforward. It's pretty simple. We could say that dv dt equals pi times that. So negative 1/10 square root h, okay? Or we could say it's negative pi over 10 times the square root of whatever h is. And remember, they told me right over here that it's when the height of the water is 4. So really, I'm going to put a 4 there. So we could simplify that a little bit more. The square root of 4 is 2. So this is really like saying negative 2 pi over 10. Reduce that by 2. You get that the change in volume over the change in time is negative pi fifths. Now let's make sure we put units of measure, like they said here, units of measure. And so let's think about this. This is a volume, right? And all the dimensions they gave me before were in feet, right? The radius is feet, the height is feet. So what would that be in volume? Well, that'd be cubic feet. And the time, what's the time that they gave me for this thing? They said that this is happening where h is measured in feet and t is in seconds. So feet per second. Or cubic feet per second. Negative pi fifths cubic feet per second. All right, there's part A. All right, let's do part B now. So part B, I'm going to do in blue. All right. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Okay, well, we have this equation still right above us. This is the rate of change. See, is the rate of change of the height of the water. This is the rate of change of the height of water with respect to time. Is it increasing or decreasing? Well, to determine whether or not this is increasing or decreasing, right? And like, I know it's negative, but to determine whether this is increasing or decreasing, we'd actually need to know the derivative of this. And yes, it's already a rate function, so really it's the second derivative of h, right? To know if the rate is increasing or decreasing, which is a little confusing. But look, it says, is the rate, let's highlight those keywords, is the rate increasing or decreasing? So that's really asking for us to evaluate the rate of the rate. So what we need is we need the second derivative, which is really not that hard to do because it's just a coefficient. if you were to think of this thing, another way you could think of this equation, I know right now it's dH over dt. You could think of it as negative 1/10 h to the 1/2, right? So if you use the power rule, take the 1/2, bring it out in front. 1/2 times negative 1/10 is negative 1/20. And then you subtract 1 from the exponent, which would make this h to the negative 1/2. And then you have to remember we just took the derivative of h, and h is really like a function in of itself, and so we need to account for the chain rule here, so we would say times dH over dt. Okay, let's clean this up a little bit. This would really look like negative 1 over 20 square root h, and dH dt is really negative 1/10 square root h. Well, maybe you'll notice here you have a square root h on top, a square root h on bottom. Those cancel out. And a negative times a negative makes a positive, so this is really a positive 1 over 20 times 10, which is 200. So it has a constant second derivative of 1 over 200, which is a positive. So for B, it is increasing. So for part B, we'd say something like d2 dH over dt squared is always 1 over 200. Therefore, it is positive, and dH dt is always increasing. I think if we say that, I think that's good enough to explain. We have our work there to show that we know that it is, in fact, positive. All right, let's take a look at part C. I'm going to do part C in black again so we can kind of see the difference. So part C says, I'll just highlight this one. At time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. Okay, so basically they're giving us an initial value of this thing. So when t equals 0, h equals 5. Let's just keep that in mind. That's going to be important. And let's go to the original equation that we have here, which is the differential equation they gave us, which is that dH over dt equals negative 1/10. I'm going to write it as h to the 1/2. All right, so separation of variables. We've done that before, but basically that's just the idea of, hey, you know what? Let's get the h's with the dH and any t's with the dt. There isn't a dt here, so we don't really have to worry about that so much, but let's just kind of clean this up. So if I did some basic algebra, some of the things that I could do here is, one, I could divide both sides by h to the 1/2. And I could multiply both sides by dt. Right? That would cancel, that would cancel. So what would we have? I'd have essentially h to the negative 1/2 dH equals negative 1/10 dt. Well, that's a pretty reasonable equation there. I know I have a number here with dt, and that's fine. I can leave it over there, and I can actually just go ahead and integrate both of these, right? Like I can just say, hey, let's take the integral of both of these. If I do that, the integral of h to the negative 1/2, I add 1 to that exponent, becomes h to the 1/2, and then you divide by the new exponent. But dividing by 1/2 is the same thing as just multiplying by 2. And over here, this would just become negative 1/10 t, and I need to throw in a constant there somewhere. I'm going to throw it on this side. Okay, a couple things here. If I look back, it did say to find an expression for h, so I do want to get h all by itself in terms of t, so we are going to get h all by itself. We'll get there in a second, but let's also think about the fact that I have some values to plug in for t and h to solve for that c. So before I actually get h all by itself, let's just go ahead and plug these in, and I can start to solve for this c value. So if h is 5, and remember 1/2 is really just square root, t is 0. Well, 0 times anything is just 0, so we get that c must be 2 square root 5. Okay, so let's go back to our equation now. I have 2 square root h equals negative 1 over 10 t plus 2 square root 5. And I'm going to just do some work here to get the h all by itself. First thing I think I could do is just divide everything by 2. And If I do that, oop, I'm running out of like some space here. If I do that, now I have that the square root of h equals, so if I divided that by 2, that's the same thing as multiplying the denominator by 2, so I'm just going to call that negative 1/20th t, and I'm going to call this plus just square root 5 now. And now the next thing I need to do is just simply square both sides. And if I do that, I get h equals, I'm just going to leave it. Remember, we don't really have to simplify here. Just going to leave it like that. And now I have an expression for h in terms of t, which is all they really wanted me to do. So there's all the parts that we need. There's A, B, and C. Hope that helps. See you guys on the next video.